We'll start. Basically, this talk is about our journey in trying to use AI in cybersecurity, and I'm going to share horror stories from the past 2 years. Well, not really. Don't make this mistake. Painful learning from applying AI in security. Let's start a little bit about myself. Eitan Worcel. On this slide, I can mention what I'm doing. After that, not. So I was born and raised in Israel, like many others in this conference. We're actually competing. 4 speakers now are from Israel. I don't know how that happened. I live in Massachusetts for the past 8 years. I moved here with my wife, 2 dogs, got another one, lost one, sadly, a month ago, and with 3 kids. I used to run long distance, marathons, ultra marathons, but if you are from the East Coast, you know that in New England, you can't run all year. So half a year you can't run, and I lost it. I'm in the AppSec business since 2007. And at the end of 21, I left my job and I started Mob, which is an automatic remediation platform. Feel free to connect with me on LinkedIn. You don't have to do it now. You can do it later. I will include my name again in the last slide. So let's start. The agenda, okay? I'm going to, for us, AI wasn't the goal, right? AI is a mean to an end. So we wanted to make sure that we have a problem that we want to solve. I'll go over the problem. I'll go over the goal of how to address, of what we expected to get from the product for the solution that we're working with, how not to use AI in cybersecurity, how to maybe use AI, how to build a solution old style, no AI at all, algorithmic style, and then how we mix the two and we feel that it works, and a summary. Okay, and as I mentioned, I go off script, so I may not follow the agenda. Let's see. Everyone knows this lovely thing, right? The DevOps infinity loop. So that worked great, right? The idea was to release software more reliable and faster. It worked, game on. And then someone that didn't read the character in the Project Phoenix that was actually doing security that was supposed to be part of DevOps realized, okay, we need to do DevSecOps. I'm not going to talk about that much. I have a talk about this tomorrow with Dustin. But from my perspective, if DevSecOps was meant to be able to release secure products at the end, at the speed of DevOps, it failed. And why did it fail? Because developers don't fix vulnerabilities, right? And if they do, you don't release it as fast. Now, before I go further, any developers in the room? Not past developers, actually working as developers today? Not many. Security people? Any CISOs in the room? I want to know who to address later. Okay. Hey, you're not going to buy my solution. Okay. Just for you to know, so a research that was done by Google and was published earlier this year, they were working on automatic remediation solution based on AI, of course. And what they wrote there is with their solution, they were able to eliminate the time developers spend on certain type of issues. And they said that the Google developers spend an average of 2 hours for those fixing, for a single issue to fix. No disrespect to your companies. Maybe your developers are better than Google, but usually Google is respected highly. So the industry standard that we are seeing is like 5 to 6 hours to fix a single vulnerability. Now, if you want to release your feature and suddenly you get stopped by a scanner that tells you, hey, there is a vulnerability, what do? You just kick that can down the road. You need to focus on delivering the feature. What happens to a can that is kicked down the road? It joins many other cans, and you get a pile. And this is where most of our industry is at. You have a huge backlog, security debt of hundreds and thousands and millions of vulnerabilities. By the way, this recording is going to be shared later, though OWASP sometimes release it 2 months after. But you can reach out to me, and I'll share the slides if you reach out over LinkedIn. You can take pictures of me if you want in the slides and post it on LinkedIn. I'll appreciate that. But you don't need it for this. So this is the busiest slide that I have, and that talks about the problem still. Security tech debt is crippling companies. Why, Eitan? We've been doing that for years and nothing happened. Well, companies that do spend time on fixing, they spend thousands or tens of thousands of hours of developers, and they only scratch the surface. And if you haven't heard, there was a talk earlier by this guy, if you raise your hand, if you missed it, on the other room. He was talking about AI and the risks with AI, code generation. Code Copilot on all the other friends can generate vulnerable code. Well, it's not can. They do generate vulnerable code because they learn from the patterns that your developers used in the past. All the idea of this, which is amazing, it's a glorious copy-paste machine, it needs to make your code look familiar to your developers, so it will use bad code that was there before. If it was in your backlog, yeah, guess what? Higher likelihood that new code will be vulnerable. But to add to that, PCI 4, anyone heard about PCI 4? It's going to be released, well, it was released in 2022. It's going to be mandated at the end of March of next year. So guess what? PCI 4 talks about fixing also. And not just the highs and criticals. There is a statement there that says, mediums and lows can also harm your application, so you need to address them. Yes, by the risk policy, but you can't just say, I'm not fixing any lows and mediums. You need to document, I'm not fixing this because I have that mitigation, all sorts of things. So if you didn't start to get ready for this, well, you should. And other reasons. So let's start. What was our goal in addressing this solution? Again, we were trying to build, well, we built a solution to fix those vulnerabilities. How do we measure the goal? We had few ideas on what we want to achieve. First of all, we want to help developers get rid of that backlog, and also help developers get rid of the chore of addressing those static analysis findings. Guess what? None of your developers like doing that. So we wanted to allow them to run faster and deliver code. Second thing, which is weird, we are in security. We actually care about the security of your companies. With a raise of hands, anyone here is tired of getting that letter in the mail that says your information is part of a data breach, and now you get an insurance for a year or something of credit score, and you still didn't leave that cell provider or that ISP or whatever. You still use it because you're a captured audience. But it's annoying. And then we wanted to minimize the mean time to remediate, the time between a vulnerability is found until it's being remediated. And last, we wanted to help you get rid of that mountains of vulnerabilities, to fix things at scales. If you don't know, some of the largest companies that you are customers of have thousands and thousands of SQL injections in their code. They have command injections in the code. Scary, I know. They have it. And they can't address it because, as I said, 5 to 6 hours to fix every issue. So this is the goal. How do we solve it? Well, before that, I said, going off script, I forgot. These are the issues that we are able to measure, and this is how I will measure the different technologies that we used, okay? Because the other things, how can you measure if developers if your product is more secure? I had a discussion with Katie about that yesterday. How do you measure that? How do you measure if developers are running faster? So let's focus on this. And how do we do that? Ta-dam, with AI. I see a few folks in my age and over, so they will recognize this character. Naturally, we are on a talk about AI, so let's see what we did. Let's start. Basically, there is a vulnerability here. What we learned with using AI, there are ways to templatize the queries, the prompts. By the way, if anyone on the back doesn't see the screen, you can move here, there is line, but then you can't leave in the middle because I will be offended. Just saying. So we learned that if you prompt it better, if you tell the AI basically, hey, I have a certain vulnerability, cross-site scripting. Vulnerability in the following, what type of the code? JavaScript code. And then you give it the code, and you tell it what to do. The vulnerability is in line this, fix it. It improves the chances that the answer you will get will be relevant. So we did it, and guess what? Ta-da, it worked, right? The vulnerability was actually fixed by ChatGPT. The samples that I have here are all with not the 01, the 4.0, except from one that I went with the last one. So yes, it's still happening. And what we see here is that the ChatGPT suggested creating H1 element and solve the problem because it was assigned to that element. So do we have a solution already? Not yet, right? We are a serious company. We want to try it to challenge it a bit more. And now we went with another cross-site scripting. Forgot the name. It's like one-click reflected XSS or something. Not as common, but still vulnerable. And we tried that. Similar approach. I have an XSS vulnerability in the following JavaScript code. Here's the code. Here's the line of the problem. Fix it. So it's small, I know. I'll make it a little bit bigger. The code, the problem, the XSS could happen is if attacker would put the payload after the question mark in the URL, and it's being used. For some reason, ChatGPT decided that there is an URL parameter in the URL, and the value will be after it. So the first line that I highlighted has no reason to be there. And then the second one was really interesting fix. ChatGPT believes, well, GenAI believes that if you do a constructor for URL, it will sanitize the problem. I thought, that's interesting. Maybe we'll learn something that we didn't know. So we tried it. Didn't fix the problem. So what we saw in this problem, this answer, two things. First of all, the fix broke the application. There was never in my application a URL parameter where I parsed the URL to figure out what is the back URL. It was never there, so I applied this fix. I need to change my code, the back end, the front end, whatever. Second thing, it didn't solve the problem, as you saw. So we went back to the drawing board and went and did a lot of research. So a small story about our history. Company started at September 22nd, 22. And anyone here remember the date that ChatGPT GA'd? November 30, 2022. Imagine you're a founder of a new startup, 5 people in the company. Suddenly ChatGPT comes and you don't have a startup. So I told the team, all 4 of them, stop what you're doing. Look at this. Maybe we don't have a company. Maybe we have a good technology that we can use. Then we were happy. It didn't solve the problem. So we started a research with ChatGPT with GPT-3. Then we did the research with 3.5, later with 4. The stats that I will show you are based on GPT-3. We did an experiment. We took 2 applications that everyone in this room probably should know about, Juice Shop and WebGoat. We scanned them with 2 commercial tools, 2 commercial SaaS tools, and we took the 100 and something findings that were there and fed them to OpenAI, similar way to what I showed you, with more information. We packed it in a way that we knew that will make it easier for the OpenAI, for ChatGPT to solve the problem. So let's start. 29% of the fixes were good fixes. What does that mean? It solved the problem. Would I fix it that way? No. Is that a best practice? No, but it solved the problem. The downside in not following best practice means that when you scan it later with your SaaS tool, it probably will report the issue again. But let's put that aside. Close to one third were fixed. Then 19% didn't ruin the application, so that's good. May have introduced a new vulnerability. We had a case where a fix for command injection introduced NoSQL injection. May only partially fix the issue. Sounds bad, right? But you see, this is the second row because there is another row. 52 were just bad. The code change was in a different place in the code. AI completely hallucinate. It didn't fix the issue obvious. Sometimes it was just breaking the code. Sometimes it just added the function, hey, validate method, validate domain, it added the method, and then you go down in the code and you see the method, validate domain, and the entire code inside is a comment, sanitize your code here, sanitize domain. Not very helpful. But the cool thing is sometimes it just deleted the line. Here is a vulnerability. I will just fix it by deleting the vulnerability. Great, right? So I want to take a quick stop. So when we did that, I gave this talk 2 days ago, and I did an experiment, which I will repeat today, and hopefully it will work. I decided, okay, maybe I don't know. I will ask the expert on GenAI. So I installed this application. People know? At home, if you see, that's the ChatGPT application. And you know what's worse than doing demo live? It's using GenAI live, because it doesn't load now. So let's try again. Because it was funny, it gave me answers that I didn't expect. We'll try it again. Elliot, are you here? Yeah, I named it.
Yes, I'm here. I'm ready. What do you need?
So you remember that conference that I talked to you about yesterday? I'm there now.
Yes, the OWASP conference, the one you were excited about. How's it going?
Oops. It's going well. I'm in a room here. We have a lot of people. It seems that they're interested, or at least enjoying themselves. And I told them about GenAI and automatic remediation. And I wonder, what are your thoughts? Can I use GenAI to automatically remediate source code vulnerabilities at scale?
There are definitely risks involved in using GenAI for that. While it can help, relying on it for automatic remediation can be dangerous if we're not careful.
I love that answer. Why would it be dangerous? Give me an example.
One example is false positives. Many static analysis tools produce them, which means you might end up fixing issues that aren't real vulnerabilities, wasting time and resources.
Okay, that's an interesting idea. Let's assume that I have a solution that cleans all the false positives. Everything that I give the GenAI is true positive. Can I then use it to fix issues at scale?
Even with true positives, you still face challenges. The fixes generated may not always be technically correct, and relying solely on AI can overlook nuances in the code or context, leading to potential issues.
Okay, so let's summarize because I need to go back to the session. What is the biggest challenge in using GenAI for automatic remediation at scale?
The biggest challenge is that we cannot assure the fixes will be correct. A human needs to evaluate each fix to ensure it's appropriate. And if we're looking at thousands of vulnerabilities, doing that manually simply doesn't scale.
Thanks, I succeeded. Elliot was awesome. By the way, I'm surprised every time with the answers, so I took a risk here. So basically, we heard it from the man itself, or GenAI to use it, there is a big risk, right? I'm not saying it doesn't bring value, but you need to know what you're handling with. And there are a bit more problems to tackle. So context windows is usually small or expensive. If you're trying to fix those hundreds of thousands of findings that you have, that can be very costly. Parsing LLM outputs, if you want to build it yourself, just know it's a nightmare. You want to automate it, so you want to use JSON format. Guess what? LLM hallucinates that sometimes. AI doesn't respect the code style. It will eliminate tabs, spaces, whatever you want. It lives in comments, so it adds a lot of comments code. And counterintuitive, the more information that you give, it actually more hallucinates. So if you give it a big file, it aims to please, so it will try to fix things that are not there. So let's go back. So AR, let's show you how we embarrass ourselves sometimes. In our solution, we have what we call experimental fixes. Where we fail, we use the AI. Here's an example, which, by the way, if you try today experimental fixes in our solution, it may happen. This is from WebGoat. Basically, remember that prompt. AI, Jen, please fix SQL injection in this Java code. Here's the code. Please fix it, kind of thing. And what it did, it just put a comment, prepared statement. OK, that doesn't help me very much. Or this one, where client hard-coded domain. So the change here is good. It changes HTTP to HTTPS. You should do that. Did it solve the problem? Not really. But you may say, Eitan, you seem like a nice guy. We had lunch. You're entertaining us. Maybe you're not the smartest person here in the industry. Here are some others. And I try to anonymize the tools because I don't want to shame anyone outside of us. So this tool, for example, was supposed to fix hard-coded secret. It replaced it with another less hard-coded secret, still hard-coded, less secret. This one, as I mentioned earlier, fixing SQL injection. It fixed the problem. There is no SQL injection anymore. I couldn't anonymize this, right? Everyone knows this tool. We know and love this tool. They are back, by the way, they released their automatic remediation a month ago. They're doing an awesome job. Out of the other tools, not us, they're the best. But basically fixing rate limit, and they removed this line for no good reason because their AI decided to. And then this is fun. You need to understand what you can and what you cannot automatically fix. This is an important lesson. Broken risk cryptography algorithm. Replacing a weak encryption key is so easy. Replace it with a strong encryption key. Boom, you just broke your application because you replaced it in one place. What about all the other components that are using it? So you need to know what you can do. Let's review the goals that we have. Are we able to minimize the mean time to remediate? Somewhat yes. If you actually know what you're doing, then you can look at the results and edit it. Can you fix at scale? Definitely no. As you heard from Elliot, right? You need to review each and every fix. Let's go on. We are evolving. We are growing. We are learning from our mistakes. We are trying different approach. So what we learn, okay, maybe we need a custom prompt per every vulnerability and maybe for every code pattern even. We need to pick the context carefully. Maybe we can only send a certain function or a code block instead of sending everything because, as we said, if we send a large file, it tends to hallucinate more. And yes, using retrieval augmented generation, can we add more information? Because we didn't train an AI. You probably won't train an AI or fine-tune it. You want to do it with prompts. And do it in several steps, so not one step on just dumping everything and expecting it to work. And last but not least, validate the results, validate the syntax. I love that you take pictures all the time. It's impressive. You will get the slides at the end. But I appreciate it. So here's the issue that we had before. Similar prompt we saw didn't work, and we added one small thing. Basically, you have to validate the URL as HTTP or HTTPS protocol. So we tell the AI exactly what to do. Did it work? Of course it did. Because we told the AI what to do, we had the exact prompt, the exact code pattern. This works, and it can work better and better over time. But there are downsides in this solution also. So first downside is you need to understand every code pattern before asking the LLM. Otherwise, you will suggest the wrong fix. And you need to understand that the code pattern is new to offer a different, to provide that context. But that's OK. So carefully picking the context. Can we ask the LLM to fix a function instead of sending the entire file? Right? We said we wanted to reduce the size of the file. If you know how TaintFlow, people know TaintFlow here? How does it work? OK, so no raise of hands. I guess you don't want to be cocky. The idea is that you have the sources of your application. You trace the value. Sources are the user input, the places that input can come into the application. You follow the trace of the data until it lands in final destination, which will be writing to file, writing to executing in database, HTTP response, and so on. So the problem is that the source of the vulnerability can be in a static variable of the class because it was assigned to it earlier, and now I'm passing a certain code. The TaintFlow analysis won't know, the GenAI won't know where the problem came from even. It can happen where the fix involves imports of a new library. Where will it put it? So let's review the goals, because it did provide value. Were we able to minimize the mean time to remediate? Yes, in most cases. Were we able to fix at scale? Still no, because every fix needed to be validated. That problem still stayed, because still some hallucinations happen. By the way, again, maybe I'm sounding persuasive, but you don't know me. Maybe I'm just acting here. GitHub published this article. Again, I love the solution that they built. And this article was published a few months ago, and they are saying it, referring to their automatic code scanning remediation, can generate fix for more than 90% of the vulnerability types, which is awesome. By the way, this is crazy. This is a lot. And over 2/3, the underline is in the quote, in the article. Over 2/3 of those fixes can be merged with little to no edits. Most of the people here in the room are technical, and some sellers. No disrespect. I did that. Sorry. Michael, I think I ruined everything now. OK, it's back. The way I read this, and sorry, GitHub, I want to be a partner, and we are partnering. The way I read this is 1/3 of the fixes might not be great, let's say that. Not I, as we say in Hebrew. And I don't know which one. So I will need to validate one by one to know which fix can work. Can I use this to fix 100 issues or 1,000 issues? Well, Elliot told us you need to validate one by one. And again, this is GitHub, like here, the best AI minds in the industry, in my opinion, in our industry. Let's look at an example. This example I actually tried on 01 preview, the latest version, not the mini, even the preview. And I gave it this code from WebGoat. And this code has a vulnerability. I made it bigger so you can see. The account name here is being brought from the outside. It's being concatenated to a query and being executed later. Obvious SQL injection, right? I asked ChatGPT to fix it, and the explanation was really good. Account name might be a problem. You need to change it to a prepared statement. Great explanation. The fix also, on paper, looks great because they created the prepared statement. Here, did the set string, perfect. What the problem is that it broke the application. And now, I'll take a pause and challenge you. Anyone here knows why it breaks the application? For those at home, the audience now are thinking. Any idea? I'll give it the TV that we have downstairs that we are raffling later if anyone knows the answer. By the way, we are raffling a TV later.
Is it the parameter type?
It's the parameter type. Never had anyone that actually knew the answer. So the parameter type, actually, if you look at the schema, and you guys will decide if she wins. The parameter type, you see account name is assigned to user ID. User ID is not a string. User ID is an integer.
Yeah.
Now, Eitan, how was the AI supposed to know that? Well, there is a way, there is a tell, because if it was a string, you would have a single quote here, and you would have a single quote here. Otherwise, it breaks the syntax of this, right? Would a senior developer that gets the results will know that immediately? Maybe, maybe not, because Chat is very charismatic and confident. But I'm sure that all your developers have amazing test cases, and you would find it easily, and it won't break in production. So, putting that aside, putting AI aside, let's try algorithmic approach. Yes, no AI at all. Let's do an old-style, pattern-based fixes. Yes, I named all the great companies that you know, like Mob, ESLint, OpenRewrite, SameGraph. They are all doing the pattern matching, right? So what's the idea here? What we need to do, we need to parse the code to AST, AppSec syntax tree. With the raise of hands, anyone knows what AppSec syntax tree is? So I'll know if I need to show the other slides. Okay, so you will wait, be patient with the others. Parse the vulnerability report, which you need to do anyway. You take the big 45 report, check marks, whatever, and you parse it. Match the AppSec syntax tree to the report, understand the code patterns, and apply the fix to the AST to generate the D file. Basically, AppSec syntax tree is a convenient way to analyze and update the code. And I created these awesome slides to explain how it works. What we want to show here is that we are taking this potential, something that will lead to cross-site scripting, and we are adding DOM purify to sanitize the code. This is a representation of an AppSec syntax tree representation of the command above. So you have the expression statement, which is everything, an assignment expression. If I'm looking at the left side of the assignment, that's the member expression, and so on, right? You see the things moving here. And then we want to add the DOM purify. So we're basically adding another node here, and we move on. So overall, this is how AST works, and that the ease of use here is that it makes it easy to put in the fix, right? That was our approach. That is what we were using SameGraph under the hood at the beginning. Still use it in some places. The AST of it, not the fixes or the scanning. So let's talk a little bit about the challenges of parsing the vulnerability report. I love all the SaaS vendors. They're all partners of mine, outside of Veracode for some reason. Some of them are using Serif. Serif is the official format that everyone should follow. Some are not following, so the fun guys are doing that. The challenging ones will use custom XML, custom JSON, or other formats. So you need to learn how to do that. And then you need to find the source. As I mentioned, the user input, all the propagators until you get to the sink, and the best place to put the sanitizer, right? This is a lot of challenges. So as I mentioned earlier, we are able to fix this issue. When you have a pattern-based rule that actually works, then it will always work. It's very simple. It's like the ESLint -- fix for something. So here's the fix. Let's review the goals. I didn't go into the details on how we do that because this is a session about AI, and I'll go back to AI soon. Were we able to minimize the MTTR? Definitely. The fixes are deterministic. Every time the same fix. Can we fix at scale? You look at the first fix, you look at the second fix. If you like it, all of them will look the same because it's pattern-based. But there are problems. Building such a tool is slow to develop. For every issue type, for every code pattern, you need to do manual work. Requires a team of security experts to research each one of them, figure out where is the best place to fix, and apply that fix. And it's hard to scale, adding more issue types, adding another language, adding another SaaS solution. And naturally, I can't stop here because you will feel misled. It's a talk about AI, how you can use AI for this. So let's go in another approach, and that's the last one that we are doing today at least. The correct way, naturally, because we are extremely objective. We believe so. And the idea here is that how can we use both AI and deterministic algorithms? So in this case, again, there's a vulnerability, no prizes here. The vulnerability here is the command may be null. How do I fix this? Do I need an AI for this? I guess that most people in the room should know how to fix it, and if not, I'm not going to challenge or shame you anyone here. Basically, you're checking if command is not null before you are trying to reach to one of its attributes. Sounds simple. Everyone should be able to do that. If you're not in the wrong, well, you're in the wrong conference. But what happens if you have something like this, where it's not just a object that dot attribute. You have a dictionary, an object of it, a field of it, so it's getting a mess. Imagine, this can go way further even. How do we write a pattern to find all this? Maybe we can use AI. So going back to the same prompt that we mentioned earlier, the same template, right? I have a null reference exception in C# code, in line, here's the line. Exact explanation on how to fix it. Surround the line code with an if sentence to avoid the null reference exception. As I showed earlier with the second level, right? It works, and it worked pretty well. It gave us the if statement, and then it added some stuff that I didn't ask it to add. But that's okay, because we're saying we are not relying on AI to fix it. We are using AI to do one step of the fix. We know the rest. So we're taking this, and we are removing the non-relevant information, and we incorporate that into our fix. Okay? When we tried this, the results were awesome. Try this at home kind of thing. Were we able to minimize the MTTR? Yes. We see the same fix over and over again. And by the way, if you don't get the fix over and over again, try again. Figure out how to tweak it a little bit more until you get the prompt to give you the results that you need. At the end, the results that we had was fixing things at scale. Can we provide a fix that you can check the fix, the first one, the second one, you will say, I hate it, I never want to see it again. Okay, I like it, apply it to all my backlog, still okay, because you can use it. You can trust that the same results will come over and over again. So, the additional value, it was faster to develop. And we're getting to the summary. I think I'm in time, I don't know. Nina didn't show me the 10 minutes, so I think I'm good. To summarize, remember, AI is extremely charismatic, extremely confident, and extremely aims to please. So this person that I probably butchered his name, Louis Lastras, sorry if I'm butchering your name, think of the model as an overeager junior employee that blurts out an answer before checking the facts. I'm sure that you all saw that. It happens. GenAI is a great tool, but it requires a lot of supervision. If your goal is something predictable, won't work, right? Usually, if you don't scope it. It helps save development time. If you weren't in the talk about AI code generation, don't expect 40% improvement of time, but it does improve the time, and it's good. Use it. If you're not using it, if your company decided, no, we are not using GenAI, start searching for a new place, because maybe 2 years you're out of the market. You'll be too slow to move. Never trust the results blindly. Someone needs to validate that, and if you're not validating it, your users, and remember, hackers are also your users, not customers, but they are your users. If you're not doing the job, they will do the job. And last, and I love this one, not because I wrote it, actually someone else helped me writing it, stop that trust but verify. Stop trusting on this sense, in AI. You need to first verify, you need to validate, and that's the new approach when it comes to AI. And last, questions. Quiet. I shocked everyone. You didn't expect this one, right? It's not my dog, by the way. It's not the one that we lost. And please reach out to me over LinkedIn. I'm not really busy on Twitter, but this is my name, and I'm the only one there. Yes. I'll stay here because I need to be recorded.
Can you hear me?
I can hear you.
So in that last portion, the fix that's created by the LLM here,
Yeah.
what was how did this relate back to the pattern matching that you talked about before with some background?
Okay. So the question was, I repeat it for the other side. The question was, you have the LLM building the fix here through prompt, right? How is that related to the pattern matching that you mentioned earlier? Are you glad you paid attention, first of all? So the story here, the pattern matching is used to identify the source of the problem, right? The root cause. The root cause, let's say, I mentioned check marks earlier, so I'll mention Snyk now. Let's say Snyk says there is null reference exception. I'm looking at the code, I'm searching for the right pattern, and I know the line, and then I know that the pattern doesn't work for me there, and I'm reaching out to the AI. I know I'm building the algorithm to fix it. I'm using the AST to put the fix inside, but I'm not using the pattern to fix it, right? Where I will use a pattern if I do a set cookie without secure flag. If I do XSS, I can use the pattern usually there. In this fix, it's AI. But still, it's not simply prompt engineering of, hey, AI, fix now reference exception in this code. I'm telling it exactly where, and I'm adding the rest of the code. Did I answer your question, or did I? You have another question, so. Yes, you were paying attention, so sure.
So you were talking about fixing at scale and reducing MTTR. Do you see any value in having this be the solutioning that feeds the pattern matching for autofixes afterward? That you would come up with a solution and then have the governance of the solution be in the pattern matching?
Okay. So the question was, we were talking about the MTTR, reducing MTTR and fixing at scale. Can we use this, the answers from GenAI, to feed the real pattern fixes that we have, so it will be fully deterministic and no need for AI at all, right? No, sadly, we tried. Because, for example, in the example that I gave here, this can look very different, right? It's not that I can have a certain pattern. It's not that I can take all those objects and parse them and break them into the if statement. Probably I could, but it will take me a month to build such a rule. And you don't have a month to spend on everything. Other questions? Yes, David.
So looks like the approach that you took, or at least that you took at the beginning with all the issues, is usually like use AI, get the answer, and then try to apply the answer. In the new world of AI agent, where you actually have, like, on one hand, like someone who is trying to research something, and then you have other agents that try to critically look at the answer and maybe ask for refining the original answer, do you believe that if you had a crew of agents, one that, for example, would try to find a fix, another would actually be a developer, so the developer would say, oh, but actually make sure that you didn't modify things that are redundant, things like that. Do you think that by an approach like that, you could actually improve the quality of your AI in the first place?
So I'll repeat this long question, although I said I won't repeat questions that I don't know how to answer. The question was, in the world of AI agents, where one agent will do this, and then the other agents will critique it and basically train it to give different answers, do I expect this to improve and to not need our solution? I don't know. I want to believe that AI will get there. I want to believe that in order to get there, you need to also have all the know-how. I do believe all the know-how and the data. And egoistically, in a way, I don't know if it's in English, but in Hebrew it works well. I believe that we will be in the forefront of that because we will have all the know-how when the technology grows there. But I don't know the answer. Anyone else know the answer or guess the answer? If you do, go talk to David later. Yes?
The research that you have done, you were giving a piece of code to the GPT and you are expecting resolution out of it. What if we integrate to an ID where the GPT has access to all the code and gives a sensible output? Do you think is that possible?
So the question was, in our experiment, we gave we give GPT a certain block of the code and told it to fix here? What if instead we give it access to all the code, whether IDE or GitHub, it doesn't matter, and tell it, here, take whatever you want and fix it, kind of thing, right?
I mean, I see clear privacy issues, but
Yeah, let's put privacy aside. Open source project, right? Your own AI. I don't know if you were in the beginning. When we gave the AI a full file, it went ballistic. It went overboard. It was trying to do things that we didn't ask it to do at all. It actually confused it more. We wanted to scope down what we do, the way that we use AI today even. We minimize the amount of data that it needs to solve the problem. Any other questions? Yes?
Have you seen any meaningful differences between different languages, programming languages?
Yes, actually yes. We are using multi-model, for example. We started with OpenAI, now we are using Mixtral. We're adding support for Python. We're using Sonnet for that because it does better on that. I guess. We're not trying to train the AI. We are following the footsteps of GitHub. If GitHub is saying we don't need to train the AI, probably we don't. They're smarter than me in AI. Any other questions? Thank you all for joining. If you want to learn more, you can stay and ask me or go to our booth and ask to see me. Thank you.